All right, so we left off the last video with the small hole mics and the telescope gauges, and we're going to pick up on the tubular inside micrometer. I'm breaking up this video series because we are covering a lot of gauges and I don't want any one video to get too long. So the next series of gauges I'm going to cover a little more complicated than we've worked with so far. The tubular mics, and we're going to cover this dial hole gauge, which is very similar to the small hole gauge. And we're going to cover this tubular micrometer. These are all, these are all much trickier to use. So they might take a little more time to explain and go over the examples. And in fact, even calibrating them can take, it took me about 10 minutes to calibrate each of these gauges before the videos. So I'm going to show you them in their already calibrated state. I'll do another video where I just go through how I set these up and calibrated them because they're quite involved. But they are very useful. I definitely recommend, if you've got these or maybe you think you need these, use them. I use the tubular inside mic all the time. So let's get back into it. The tubular inside mic is going to come with a range of Anvils that you can see here, and they will attach to one or both ends. This is a style of micrometer that was only going to exchange one end. So I'm going to pull out this piece, and you can replace it with any other anvil that you may need. So depending on how big your hole is, now I could do that's probably about 8 inches. Yeah, about 8 to 9 inches. So the number of anvils you have in the set is going to determine how big you can get, and the size of the body is going to determine how small you can get. So one of the ones I used to work with a lot only would start at 4 inches in size because the size of this body was so large that 4 inches was the smallest that would fit in there. But then we could go up to, I think that setup could go up to 32 inches because we could take an anvil and we could register an anvil on both sides of the micrometer to get really large diameters, which I was working with at that company. So this one, you can exchange this end, and you basically just slide it in until it stops, and then you lock it down. So first thing you're doing when you're using a tubular inside mic is you're gonna build the size you need. This set, it either lost a chart or it didn't come with one, but a lot of times they'll have a chart that says, look, if you want to measure between 12 and 13 inches, grab these two sides, put them in, and then you'll be able to meet the 12 and 13, depending on how far this travels, in terms of how long this micrometer spins. So next thing up, you're going to close the gauge so that it can fit in the part, and then you're going to anchor it on one side and slowly open it until it starts to register on both sides, and then you're going to try to pivot this thing so until it reaches the high point. So let's go through this this procedure real quick. So I've chosen the size that fits in this this sleeve here, and if we take a look at this micrometer, it opens up, starts at 0. You get some of the focus. There we go. So it will go open up to about 0.55. Let's see, how far will it go? That's about it. So this range is about a 1/2 inch range. So first thing I'm going to do is I'm going to close it. I'm going to make it as small as I can so that it'll fit in the hole. So I'm getting close to 0. And you can see it easily fits in the hole. So next thing I'm personally going to do is there's a mark here, this this R. I'm going to use that as my guide for where I'm going to register this thing. So I'm going to put it vertical, and then I'm going to anchor it on the bottom side here, and I'm going to open up Open up the gauge. This one's sticking a little bit, so it's a little bit tricky to deal with. So I'm going to open it on the outside. Still loose. I'm going to keep opening it. I've got it anchored on this side, and I just keep bringing it out. Just keep bringing it out. All right, now I've actually brought it out too much because I'm going to try to rock it through, and I can't rock it this way. So let me close it again. And as you have it anchored on one side, you're going to have to pivot it up and down and left and right. And as you move in closer and closer to the size, you're going to have less and less range of motion. So I'm going to kind of eyeball it flat, and then I'm going to go left and I'm going to go right. And you can see I've got a huge range that it allows me to go. So I'm going to bring it out a little bit more, go left, go right. I can still bring it out quite a bit more. Okay, there we go. Getting a little closer. So left and right is stopping. I'm going to verify up and down isn't already too far. This can be very tricky, but with enough practice, so you'll get the hang of it. So left and right again, up and down. And I'm going to kind of aim for where I think the middle was, and I'm going to keep doing that. And I'm going to loosen it and go back and forth until I feel like it's no longer wiggling. All right, now it's pretty much stuck. It's probably stuck a little too much. I can't pivot it in and out. I can't pivot it left and right. So I'm going to back it off. And right about here, I can feel it just start to grab that perfect slip fit we're always looking for. Okay, so it might be, there we go. Left and right is pretty much non-existent, and I can just barely slip it through. So one good way to test if you've got a good one, when you feel like you're there, I gotta open it a little bit more actually. When you feel like you're there, you can spin it, okay? If it spins, rotate that. If it spins without flopping around too much, and it may fall because of just how delicate it is, but if it's not flopping around drastically, maybe I'll open this up a tiny bit so that it doesn't quite fall. But that's closing it. When it spins well, here we go. It's spinning pretty well at that spot, and only that spot. So one of the tricky things when you're measuring a large diameters with one of these is diameters tend to be out of round, right? So it'll be egg shaped, it'll be an ellipse, an oval, something like that. So you may find that one exact spot where it goes across, but you move to another spot and it's too loose or it's too tight. And that's what we call circularity error or cylindricity error. And it's a GD&T type of error. So as you're going around, the larger and larger these diameters get, the more common that is. You can even see it with calipers sometimes. So it's that drastically out of round. 10,000ths on this wouldn't even surprise me. I've seen that on some larger parts as well. So go around. If you're going to have to do a diameter like this, you're going to have to go clocking wise at a few places. I would say for something about this size, 3 places would make sense. Maybe just 2. And you're going to have to go axially at each depth because, again, it's got to be in print at every single location. So when you compare using this gauge to using let's say a self-centering gauge, right? Which one do you think is a lot easier? I much prefer to use the 3-point hole mic. It's much quicker. If I had one this big, it just self-centers, ratchet it in, and you're ready to go. So what I haven't talked about, what I've neglected to really mention so far, is how do we read this thing? I've just spread this across, and it's pretty much like a telescope gauge. I've got 2 points. This thing has a vernier scale on it, but why didn't I try to calibrate it? Why didn't I try to check it like I always tell you guys to do? Well, the truth is, for many places, and this is what I do as well, when you're using a tubular inside mic, we treat it like a transfer gauge. So just like the telescope gauges we did in the other video, we're going to treat this like it's a transfer gauge, even though it does have a a scale on it, and the telescope gauges don't. When see that scale there, that vernier scale, the reason for that, these are very hard to keep in calibration. There's so many interchangeable pieces. They're so big that it's hard. It's expensive. It's certainly possible, and if you're gonna do it, you know, go right ahead. I'm not gonna tell you not to, but a lot of places are just gonna verify this distance with an outside micrometer. Okay, so they'll take a calibrated outside micrometer and they'll measure across this distance, and that's how they'll do it. It'll be a transfer gauge, and it's actually very accurate that way, as opposed to trying. If I had to choose between trying to read this or measuring with an OD, I would measure it with an OD mic every time. Now, unfortunately, I don't have the OD mic in this size. I don't have one quite big enough, so we're just going to do a quick caliper check. I do not recommend you do this. I recommend you get the proper mic, but I just don't have one available right now. So if I try to sweep it across, say about 3.159 is where the size of that hole is at that spot. Right? That's one of the reasons I marked. That's why I showed you where I'm going to be on the R. Right? I'm going to be starting right there on the R, so that I can track my clocking. I can track how far I went axially. Now, if you are going to treat this like a direct measurement, you're not going to use an OD mic, you're not going to use you're not going to use it like a transfer gauge. What you can do is you can grab a ring gauge. Actually, this might be might be this size. Yeah, it's not this size. You can grab a ring gauge at a known size. This one is a known size of 88.855 millimeters, and you treat it like the ring gauge we used with the 3-point hole mic. You just go through that same process, and let's just see what this vernier scale reads versus what it's supposed to be. So we know it's supposed to be 88.855. If you can see me, I'm expanding this, and I am repeating that measurement I just did. It's hard to see with my hands in the way, but I've got it anchored on this side, right? And I'm doing all my pivoting and rotating on this side. So I'm going left and right, and I'm going up and down. I'm just guiding it with my other hand. And then I'm going to give it a spin. That was probably not quite right. It fell out right away. All right, that feels pretty good. I'm going to give it a spin. Feels pretty good, nice and not wobbly. I'm going to sneak it out. So 88.855. I converted this earlier. It's 3.498 in inches. And what does this read right now? If this is calibrated, let's see. Oh, I've got this stuff out of the way so you can focus. And it is, I would say 3.499 and a half. So it is 1,000th out of calibration right now. Based on this ring, with this anvil, the way I assembled it. So keeping this in calibration, a lot harder than keeping one of these in calibration. So we've already talked about that. So that's why most people treat it like a transfer gauge. Now, there's a few other styles of sets. It can be very easy to accidentally jostle these loose. But I want to show you one feature Some of them are going to come with these sleeves. So with those sleeves, you can kind of extend the range of the anvil. So you'll take the sleeve, you'll slide it on to the anvil you're dropping in, you'll push it on, and then you'll lock it down. So looks like this is it's about a 1/2 inch spacer. Gives you some more flexibility with all these pieces. You might find that one of these anvils is too short and one of these anvils is too long. And you're just going to have to put a sleeve on the short one to give you the extra stroke you need. Some sets will even use 2 or 3 sleeves to give you the full range of motion. So take a look at that. Some will have another connection point on the other side that's identical to this one. So they're pretty handy if you're working with large parts. But it's difficult to keep in calibration. So let's switch back to the presentation and cover anything else we might have missed on tubular transfer mic. Okay, so pretty much went through all this in the live demonstration, and I mentioned this is how you would do it with a micrometer. It can be a little bit tricky to hold a big micrometer and this gauge at the same time, especially as they get larger and larger. So one thing you can do is you can grab a micrometer holder and clamp your micrometer into the holder so that you have a free hand. You're not needing to hold it. You're not needing to hold the micrometer and rotate the spindle, keep everything steady. Another technique I sometimes recommend, it may be hard to show on camera here, but take your mic and just rest it on the rock. And then you can hold with your left hand, you can hold the micrometer that you're trying to measure. With your right hand, you can twist the dial. With a big enough gauge, it should be heavy enough to just rest without an issue. So that is what I recommend if you have a much larger gauge. It can be easier to set it down on anything, a case, a rock. It doesn't need to be a rock, but you just need to have it propped up a little bit. Okay. So next up, we're going to talk about the dial bore gauge. And if you thought the tubular mic was complicated, the dial bore gauge is much more complicated. So let me clear out a little space, and I will break out the dial bore gauge. So this dial bore gauge is set up to read anywhere between 2 and 6 inches. And it does that across this anvil here on the bottom, which rotates the dial. I'll show you on the second camera as well. So there's a little sensor down here where my thumb is, and as that depresses, it moves the dial. So you can measure a diameter at 2 points. Now this one is set up for between 2 and 6 inches, but the way you achieve 2 and 6 inches is not with just one anvil, but again, we have multiple interchanging anvils. Okay, so I have a set here of multiple interchanging anvils that will attach at this point right here. So one of the great uses for this is you can get very deep bores. I mean, look how long this goes down. You can get bores that are very deep. I think one of the first applications was for engine cylinders, where you needed to have it inspect throughout the entire bore. It does measure with 2 points, and some of the larger gauges will have a set of stabilizing wheels that will self-center it for you in one direction, but you're still going to have to rock it the other direction. And in fact, I mentioned there's a 2 to 6 set right now. Actually, I have more gauges for other ranges. So this one ranges from 0.7 to 1.4. This one measures from 1.4 to 2.5. And this one measures from 2 to 6. This one has the interchangeable dial indicator on it. You can take this off and plop it onto these two. And not only that, but each one of them has their own set of interchangeable spacers. So it can be a little bit complicated, but to get a complete set. But sometimes it's worth it. So how to use one of these is you're going to have to zero this thing on a ring that you know. It can be a ring, or it could even be some Joe blocks, but you're going to, just like everything else, you're going to zero it on something you know. And in this case, I believe I zeroed it. Yes, I believe I zeroed it on this ring so that we could measure this part. Yes, that's correct. So you're going to zero it, and then you're going to measure something else, and you're going to look at the difference, right? So you look at where the dial is on your zero gauge, and then you look how much the dial moved to get to your part. So it's kind of a transfer shop math type of measurement. You set your zero, and then you watch how far did the dial move from zero. This is one of the few gauges where you do something like that, but it's also one of the gauges where everything is in flux. This dial is not fixed in place. You have interchangeable anvils down here, so there's a little bit more complexity to it. So I've already got this. It took me, like I mentioned before, it took me about 10 minutes to get this set up and ready to go. So I'm going to show you how to use it when it's already set up. So I've got it zeroed. And just to take a measurement, I'm going to try to show this on the main camera and the secondary camera. So first of all, we've got this spring-loaded piece, this guide that will allow you into the hole. So you're going to be pushing against this to take your measurement, and you're going to be pushing down here on this little nub right here is what's going to move the dial. So I'm going to be pushing on the nub, and it's going to move that dial. Okay. There's a range of travel. You need to pay attention to your range of travel on the small dial as well as the big dial. But on the small dial, you're gonna see where it strokes out. It strokes out there. It strokes out there. Right. So one of the big issues with using one of these gauges is it strokes out before you reach your measurement, and you have to reset everything. That's why it took me a few tries. So let's take a measurement. I'll show you how to do it. So I'm gonna depress that spring-loaded section in. There we go. And let's see. I'm just hitting the camera there. So there we go. So I'm going to lower it down, try to avoid the camera. And this thing pretty much self-centers on the diameter itself, but not the pivoting this way and this way, right? So I need to pivot it in and out. And what you're going to see, hopefully you can see it on the main camera here, that dial has an inflection point right about there where it flips back and forth. So that is the point, right where it flips is where you want to take your measurement. So I'm gonna take my quick look. All right, so I'm looking at, can't see it, but I'm looking at the small dial and I'm looking at the big dial to see where they are. The small dial is between the 0.01 and the 0.02, and the big dial is just about to 0. So I'll try to demonstrate that inflection point off camera with my hand. It's inflecting right about here, right? I'm seeing the inflection point right about there. So that tells me if I know where this gauge zeroed at, let's say it zeroed here. I'm telling you, it's really takes some practice to really understand how it works. But let's, for the sake of this example, we say we zeroed it here on a known diameter, and then it moved all the way to about here where it started to have an inflection point. You're going to track how far that movement was, and you're going to do some math. So I'm going to show you an example, the example I did for this part. So there's another layer of complexity I haven't mentioned yet. And that is due to the fact that well, you get a very small range of travel off of these. And in fact, the gauge that I zeroed on is so far different than the part I measured. I had to change this anvil. Okay, so I had to pull out a different anvil and slide it on to the sleeve, which I'm going to demonstrate when I'm done. So that's another layer of complexity, which I'll go over, but suffice to say, you want to try to get as close as you can to the size that you will be measuring. And one thing I've recommended to people is if you're going to be, let's say this is what does this end up being? This is a 3.15 inner diameter. You want to try to zero this on 3.15, and then you just look for how far from 0 you are, and that'll be a lot easier. That'll be the easiest way to do it. So unfortunately, I don't have a ring at 3.15. I have a ring at, what is this at? 2.836. So I'll walk you through the math that I used. All right, so my known calibrated ring is 2.836. I know that. And I added anvils. I added 2 anvils to this assembly, a 0.120 and a 2.756. When I went to measure the part, I removed those, which is why I'm subtracting this from the calculation. And then I added 2 other anvils. So I had to zero with these 3. I had to set my 0 with these 3 to start off with. And then I had to change those 2 out. So I replaced them with the new values, which I'll show you in a second. And when you get through all that zeroing, when you figure that out, you're at 3.150. Okay, so that is, I told you this is a 3.150 bore. And when I got through all of this calculation, I'm back to 0. Okay, so next thing I did, once I had the new anvils on, which is right here, once I had the new anvils on, I ran the part through. All right, so I'm going to demonstrate what I see here on the camera. This is what I'm seeing right about here. And I know from the way I set this up that I started at 0 here, and I went all the way around 9.5 tenths to where that needle stopped. So I am going to add 9.5 tenths to my final difference. If I zeroed on 3.150 and I measured that same number, when I look at this dial, it should be at the same spot. Okay, but I got a little bit of a difference. I got 9.5 thousandths difference, so that becomes 3.1595. And as a quick sanity check, because of how complicated this is, I'm going to pull out the caliper. So it's 3.152 in that spot. Let me rotate it around. 3.156 in that spot is identical. This is pretty much showing you that the out of round condition of this part. So getting, after all that math, getting 3.159 feels reasonably close, but it's not easy. So it's kind of rare that you're going to have the right ring gauge to set this up exactly. But if you don't, you can do this math. So let me flip back to the presentation and talk about how I achieve this. So basically, you have these anvils, and each one of these anvils is marked with a size. So that's where I got these subtracted numbers, is these sizes. I got it from the markings of the anvils that I picked, and I not only picked this large anvil, but I also picked one of these sleeves, because just like on the last gauge we talked about, I had to slide a sleeve over here to get the range I was looking for. So that's why there's two numbers here. This 0.120 is the sleeve I used. If you don't need a sleeve, you won't have it. It'll just be one number. So those 0.120 and 0.040 are the sleeves I used, and 2.756 and 3.150 match the pockets that I took it out of. So that's where I got those numbers. Those numbers will help guide what size hole you can measure. So take a look at those before you get started. And let me show you that on the other camera. So here I have all the different sizes. There's the washers I used. I set aside the washers I used for zeroing. So I have these two washers that fit here. Sorry, these two anvils that fit here and here. That's where I got those numbers from. So when you're going to go to interchange an anvil, all you got to do is open up this sleeve. This comes off. These things are manufactured to precision register on this face here. So here's the other sleeve that I used for a little bit of a spacer. Don't have to use it. And if you don't want to, you can change that. Maybe you want a larger one. You can drop it on and then tighten it up and go through your zeroing process again. Okay. And if you need a spacer, maybe this one's too short, but the next one's too large, you grab a spacer. Let's grab the big one so you can see it. Slide it on, slide that on, and ready to go. So that's how this set works. And give you a quick peek of everything that this 3 this 3 gauge set includes. So it's got multiple anvils for each size that you're working with. So this is a very nice set. I'm going to do another video where I show you how I set all that up, because That even took a little while, only if you're interested. So I mentioned looking at the dial is important, and it is because, in fact, this dial is free floating. It's clamped in right here by this this little knob here is locating the clamp. But if I loosen this knob, this dial will free float, and that is what you want because you need that in order to set the stroke. In order to get the stroke of the bottom in the right range to move the dial, you have to kind of free float it, and that takes some time and that takes some skill also. So setting these up can be tricky. But I want you to note that secondary gauge is going to tell you your travel. And what I usually tell people is when you're setting your zero, aim for the middle so that you can go plus or minus a small amount. And then if you end up having to reset because you run out of stroke, you should know which direction you need to go, whether you need to go closer to the left or closer to the right. But it probably will be an iterative process. It always is for me. I'm sure if you use this thing every day, you'll have a better understanding of it. But pay attention to that secondary gauge so that you can control the stroke. And this just goes into, again, maybe if you get more experience and you don't want to zero, if you don't want to center that secondary gauge, you can try to cheat one way or another. If you know, yeah, I'm going to zero on one diameter, but I know the hole's bigger, so I'm going to cheat. I'm going to cheat a little smaller. Or it's the other way around. You're zeroing on a bigger ring than you have for the hole, so you're going to cheat the other way. This is the adjustment knob as I have identified there on the picture. I'll let you physically move this thing. This thing's already set up and it took me a long time, so I'm not gonna mess with it, but I will do another video where I show you. There's a couple alternative setting methods which are actually pretty handy. One method is you can take a calibrated outside micrometer and you can open it up to the size that you need, lock it in place, and then rotate, pivot this dial in. You can clamp this on a clamp like I showed you earlier. And if let's say you had to measure a 3-inch bore, you set this at 3 inches, lock it in place, and then you go through the process of pivoting this, setting your strokes, and setting this zero at 3 inches. And then all you gotta do is look for the difference between the hole and the 3 inches you set at. And that's actually probably an easier process than what I just showed you, but setting it up on the, setting this up can be a little trickier. So give that a try, try to get the feel for that. I feel like setting it on a ring is a little bit safer, but it adds that extra complexity if you don't have a ring near the bore you're going to be measuring. And if that's the case, set one of these OD micrometers at the size you're going to do, and then go through the same sweeping process on a 2-point mic that you did with a telescope gauge and the whole tubular hole micrometer. Do the same thing. You can also do this with Joe blocks, as this picture on the right side shows. And you can set up, let's say, again, we'll use that 3-inch example. We'll take a 3-inch block. We'll just grab any other sizes. We'll go through our Joe block stacking process, which I covered in another video. And you just basically, now you have a 3-inch distance between these secondary blocks, and you go through the same procedure that the micrometer is showing. This is a little bit more precision, but you're probably going to need a clamp like that picture has. So I don't have a clamp here. I really wish I had all these tools that I'm telling you about, but it wouldn't be realistic for me right now. So I'm showing you the most common ones, but take a look at clamps like that. They're not too expensive if you want to stay less than 6 inches. They're pretty reasonably priced if you end up doing this type of work a lot. So we haven't talked about accuracy yet. In the previous gauges, we talked a little bit about, the accuracy on the whole mic is comparable to a standard mic. Transfer gauges, I didn't even mention it because they're transfer gauges, and the micrometer is what's going to take up the accuracy. With these, actually get really accurate, 80 millionths on this one that I demonstrated here. And that comes to the dial indicator and how well this is all manufactured. So sometimes it's worth going through all that effort to set it up if you've got a really tight bore. And hopefully you've got the rings in the right size to make it easier. Now I have a last kind of tricky gauge I'm going to show you is the small hole dial gauge. Very similar in concept to this. If you married it to a small hole gauge, right? If you put a small hole gauge and put a dial on it, what you're going to end up with is exactly that, a small hole gauge with a dial on it. So with this, it just measures the same way. It's kind of a lot easier to deal with than the small hole, the dial hole gauge I just showed you for the last 20 minutes or so. For one thing, this dial doesn't remove. It's fixed, and these different anvils just screw on. So you have the same idea of it's spreading it across, and you have ring gauges. So let me show you. Let me show you on the other camera. Throw this away. This will be the last thing we cover in this lecture, and then I'll do one more video summarizing everything we've talked about. Can't open. Here we go. So this is the set that gauge came out of, and you see it has a wide range of interchangeable anvils that screw on, and it has a setting ring for every interchangeable anvil. Now, I've already got this set up, so let me show you how I did that. I've got a 0.650 setting ring, and I'm going to compress that sleeve, and I'm going to try to pivot that thing, and I'm looking for the inflection point. There we go. Now you can see everything. Looking for the inflection point. It can be a little tricky to hold everything. There's the inflection point. It's close to zero. It's kind of be kind of tricky to show you. And there, it's a little bit closer. Trying to pivot in, it's not easy. But then you can rotate this dial to make it go to zero. So if this is a 650 ring, well, we can measure the counter bore on the angle block, and we can get relative to that 650, okay? But I skipped one important step. That secondary dial, we got to take a look at where that secondary dial is. So by my eyes, that secondary dial is on the third line, okay? Shows up better on this camera here, but that secondary dial up here in the face is on the third line. So I'm going to look at where that moves to, and I'm going through the same process of sweeping it, looking for the inflection point. So my inflection point is at about the 12 or 13. Oh, there we go. There we go. Maybe the 14 and a half. And then we're going to look at where that dial is. So I went from the third line to about the sixth line. And one interesting thing about this dial, it goes 0 to 80. It doesn't go 0 to 100 or 0 to 50. It doesn't go to anything that's kind of reasonable. So it goes 0 to 80. So we had 3 rotations of 80. 80 times 3 is 240. And then it was inflecting at around the 14. So that would be 254. Okay, so it traveled 254 from 650. And when 650 was at 0, all right, and then as I make this thing go smaller, that's the direction of travel. So I made it, this hole is about 254 smaller than 650. I don't think I can do that math in my head and think out loud, so I'm going to do that on the whiteboard. So 650 minus 0.254 or 0.6, 514, 9. $396. And I'm not sure that's right. I may have made a mistake in my math somewhere. I'm not feeling like that's right. So I'm going to 625. I know what my mistake is, and I'm sure some of you have already figured it out. I moved the decimal one place too far. Let's do this again. It's actually, because of the way the dial is set up, it's 0.650 minus 0.0254. Let's see what that does. So that becomes a 3, 10, 9, 6, 4, 1. Well, this is embarrassing. I literally just cannot do math at the moment. So when in doubt, grab a calculator. So 0.65, delete all this. 0.6500 minus 0.0254. 624.6. Does that make sense? I apologize for my lack of ability to do math at the moment. My brain is a little bit tired. So 624.6 versus 624 with a calculator, with a caliper. So I hope that demonstrates the need to verify when you're using a caliper in a new gauge. It always pays off. That's why I have it nearby every time I'm doing something that I don't do every day. So that's how you use this gauge. A little bit easier to use than the dial bore gauge because of the fact that there's less interchangeable pieces. I'll show you how to interchange one of these. It literally just screws off. And there will be a pin in here. You don't want to lose this. So you can pull the pin out and slap on a new anvil, drop the pin in and screw it back on. And anytime you need to zero, because it's moving by 80 thousandths, you will need to zero occasionally. You can just spin this dial. And so I got pretty close just eyeballing it. But when you're not trying to do it on camera, it's a lot easier. So you can rotate the dial. Overall, whether it's better or not than a small hole gauge, these are not incredibly common. I haven't seen them very often as I have the dial bore gauge, because I think, let's talk about a trade-off. Would you rather use this or a pin gauge? By definition, it's a small hole gauge, and we've got pin gauges up to 1 inch. At least a lot of places will. So I think that's why these aren't as common as pin gauges. All right, let's switch back and wrap things up. All right, so that's the last gauge I'm going to cover in this video. And we're going to do one more video, should be a lot shorter, just summarizing all the different gauges we've looked at. Give you a little preview here. I do want to thank you guys for watching again. Keep checking out the website, pragmaticmetrology.com, for other videos. And I also want to thank, as usual, the Laney Machine Shop machine technology program provided these parts here. They provided the tools, and it's a really great program if you want to learn about stuff like this. Manual machining, CNC machining, inspection, CAD design, CMMs. They've got a great program there. If you're in the Oakland Bay Area, please check out their course offerings. They offer certificates and apprenticeships that will really help you in your career. And they've got a great set of instructors that will help you learn about all of this and many other things. So please give them a check. Please check them out. And again, please visit the website, look for more videos, and check out the next video where I summarize all the different hole inspection gauges. Thank you.